let's see if we can help you guys a little bit, okay? Alright, numbers 1 through 12. We're going to match up the correct term with the correct segment or circle or line, okay? So here we go. Let's start off with number 1, PT. Let's look at PT down here. And here's PT from here to here. PT would be a radius. So number 1 should be letter E, okay? Hopefully you see that, okay? PT is a radius, alright? Number 2 we have, number 2 we have JK, line JK. So let's find line JK. Here it is right here. Now, listen to me please very carefully, students. Do you notice how this line is tangent to two circles, okay? So we know for sure it is a common tangent, okay? But is it a common external tangent or a common internal tangent? That's the question. Well, if I were to draw a line that connected the center of this circle over to the center of this circle here, would this common tangent line cross that red line? Yes, it would. So we call that a common a common internal tangent, okay? So line JK is a common internal tangent, okay? Letter H. Alright, number 3 is line TW. Line TW, here it is right here. There's line TW, okay? Well, that's a line that intersects the circle in two places. We call that a secant, okay? A secant line or a secant. So that's going to be letter J. Letter J. Alright, moving on to number 4. Segment MN. Segment MN. Well, here's segment MN. It's a segment whose endpoints lie on the circle. Okay, that's going to be a chord, students, a chord. So number 4 is a chord, which would be letter C. Okay, letter C. Alright, moving on to number 5. Point M. Now, point M lies on the circle, but notice also something else about M. See this blue line right here? Notice how it's tangent to the circle, and it's tangent right here at point M. Well, remember, when a tangent line is tangent to a circle at a given point, we call that point the point of tangency. The point of tangency. So letter M is going to be, number 5 is going to be letter F, the point of tangency. Alright? Alright, moving on to number 6. Point P. Well, point P is the center of a circle. It's the center. So number 6 should be letter A, center. Alright, number 7. We have circle P and circle R. Circle P and circle R. So let's see what those would be. Oh, okay, look right here, guys. I have a radius of 5 for circle R and a radius of 5 for circle P. So two circles that have the same diameter or radius are said to be congruent circles. So letter I, congruent circles. Okay. Number 8, UV. Segment UV. Well, here it is, guys. That's a chord that passes through the center of a circle. What do we call a chord that passes through the center of a circle? We call that a diameter. Okay. So number 8 is going to be diameter, which is letter D. Letter D. Number 9, line XY. Okay, here it is, line XY. Now, students, look. Notice that this line that I just highlighted in red is tangent to one circle and tangent to another circle. So we call that line a common tangent. The question is it a common internal tangent or a common external? Well, here's the two circles it's tangent to. Draw that imaginary line from one center to the other center. Does this common tangent intersect this line here? Obviously it doesn't. So we call that a common external tangent. Common external tangent. And so that's going to be letter G for number 9. Letter G. Okay, number 10, letter Z. Letter Z is just hanging out here in oblivion, and we call that the exterior of a circle. It's not on the inside, and it doesn't lie on the circle, so we call that the exterior of a circle, and exterior point would also be the same thing. So letter L, okay? Okay, point L for number 11. Point L is right here. That's on the interior of a circle, okay? So we're going to call that an interior point, or the interior of a circle. Letter B. And then lastly, on to number 13. Numbers 13 and 16, the directions say to find the radius. So if I have a diameter that's 11, now think of a circle. That's a really good circle. If I have a diameter that's 11 all the way across, cut that in half, and you'll have the radius. So if the diameter is 11, you take the diameter, you divide it by 2, and there's your radius, 5.5 centimeters. Okay? Alright, moving on to number 16. If I have a diameter that's 6 square root of 3, so here's my circle, here's my diameter, and my distance all the way across is 6 square root of 3. I'm going to take that and divide it by 2. Now, if I divide this by 2, remember outside numbers can be reduced, okay? So, this is an outside number, it's not under a radical. This is an outside number, it's not under a radical. So 2 goes into both of them. So 2 goes into 2 once, 2 goes into 6 3 times. So if I divide 6 square root of 3 by 2, I get 3 square root of 3 for the radius. So what I wanted you to learn here is whenever you're given a diameter, divide it by 2 to find the radius. Now for number 17 and 18, whenever you're given a radius, multiply it by 2 to find the diameter, okay? So here's your radius, 18, and they want to know what the entire diameter is. So multiply it by 2, and there's your diameter, okay? So whenever you're given a radius, multiply it by 2. Alright, number 18. So here's our circle. Here's our radius. Okay. Now, we're going to multiply that by 2. So we have 2 square root of 10. It's that simple. Whenever you multiply square root of 10 by 2, it's just 2 square root of 10. Okay? So, there is my diameter, 2 square root of 10. Pretty simple, guys, okay? Alright, moving on to number 23. The larger wheel has a diameter of 1.5 meters. The ratio of the diameter of the larger wheel to the diameter of the smaller wheel is 15.4. What is the radius of the smaller wheel? Well, guys, we really, from learning proportions and all that stuff earlier, this should not be too difficult at all, okay? The ratio of the larger wheel to the smaller wheel is 15:4. So write that down, okay? So up here we have diameter of, I'm going to put diameter of larger wheel. Down here is diameter of smaller wheel, okay? That's pretty obvious. No problems with that, okay? Now the larger wheel has a diameter of 1.5, so I'm going to put equals, and I'm going to put 1.5 right up top here, okay? So 1.5 will be up top here for the larger wheel, okay? So the larger wheel has a diameter of 1.5, so I put that up top. The smaller wheel has a diameter of x, okay? Now, I know we're looking for the radius. I understand that. But right now, everything so far has been in diameter, 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 okay? So, let's go over this again real quick, then we'll finish the problem. The ratio of the diameter of the larger wheel to the diameter of the smaller wheel is 15:4. The larger wheel has a diameter of 1.5, okay? So, how can I find the diameter of the smaller wheel? Well, so that my ratio is like this. So 15 times x would be 15 times x. 1.5 times 4 would be 6, okay? Now, divide both sides by 15, and you're going to get 2/5 or 0.4. I'm just going to go ahead and put 0.4, okay? Now that's the diameter. Remember, everything's been in diameters. This is the ratio for diameter to diameter. This is the diameter of the larger wheel. So this is the diameter of the smaller wheel. Okay. Now, if that's the diameter of the smaller wheel, 0.4. Okay, guys, I had to pause the video. Sorry about that. Okay, if 0.4 is the diameter of the smaller wheel, then how do I find the radius? Divide it. 0.4 divided by 2. Okay, because if you have a diameter and you want to find the radius, then you just cut it in half. Okay, so if you do that correctly, you're going to get 0.2. So the radius of the smaller wheel is going to be 0.2 meters. Okay, moving on to numbers 29 through 32. Alright, first of all, in 29, they want us to name two secants. Actually, I'm incorrect. There's two secants, secant FA and secant EB, line FA and line EB. So there's two secants, okay? Name two chords. Now there's plenty of chords. We have chord GD, chord HC, chord FA, chord EB, or in other words, segment GD, segment HC, segment FA, segment EB. Any of those two would be acceptable, okay? True or false? The diameter of the circle is greater than HC. Well, guys, of course that's true. Look at guys, the biggest chord in a circle. I mean, think about this. The biggest chord in a circle is going to be the chord that passes through the center. So the biggest chord you can ever draw is the diameter, always. Okay? So the diameter of the circle is greater than HC. Of course it is, because HC is not a diameter, and so it's not going to be as great as the diameter. So the diameter is definitely bigger than HC. That is true. Okay? Now, if triangle IJK were drawn, triangle IJK, so here's I up to J, over to K, and then down. If you were to draw that triangle, one of its sides would be tangent. Which side is it? To be honest with you, I mean, it's going to be KJ, okay, right here. But it's really hard to see with the naked eye. Maybe you would want to use a straight edge or a ruler or whatever, okay? But KJ would pass through the circle in two places. JI would pass through the circle in two places. But KJ would just barely nick the outside of the circle right here, okay? So JK or KJ would be the tangent line, okay? Alright, moving on. Number 33. In a circle of radius 12, a point that lies less than 12 units from the center must lie in the interior. Well, let's see. Here's a circle. Here's a radius of 12. Any point that's less than 12 is going to be inside the circle. Think about it, guys. From the center. Now, any point that's greater than 12 units outside from the center, any point that's greater than 12 units from the center of the circle would be on the outside of the circle. Any point that's exactly 12 units from the center is going to lie right on the circle. So a point that lies less than 12 units from the center must lie on the interior. That is totally true. Yes. Okay, number 34. If circle P has a radius of 16, so let's make this 16, okay? And let's call this circle P. And AP equals 16. So put A right, AP equals 16. Does A lie on circle P? Well, guys, of course it does. That's true. Look, if circle P has a radius of 16, okay, and then you draw a segment AP so that it has a length of 16, then A must lie in the circle, because if AP equals 16, that means the distance from P to A is 16. So then A does lie in the circle. Yes, it does. That's true. Number 35. Two circles can intersect in exactly three places. False. There's no way, guys. Look. Two circles can intersect in two places. Okay? That's possible. Two circles can intersect in one place. We call them tangent circles. That can happen, okay? However, there's no way you can get a circle. Now, two circles can intersect infinitely. Two circles can coincide and lie right on top of each other, okay? If I have two circles like this, okay, and this circle here falls right on top of this circle here, then they coincide and they intersect infinite times. Okay, infinite times. But you can never get a circle to intersect 3 or 4 or 5 times. They're either going to intersect not at all, or once, or twice. So not at all, or once, or twice, or infinite times. But no, No, they cannot intersect at exactly 3 points. No, that is not true. Okay, moving on to number 35. It's kind of a trick problem here, 36. It was proven that for any three circles with no common points or common interiors, there are 8 ways to draw a circle that is tangent to the given 3 circles. Okay? The red, blue, and green circles are given. 4 ways to draw the additional circle tangent to the 3 given ones are shown. Okay? So it says sketch the 4 other ways. To be honest with you, it's kind of a problem I want you to think about a little bit and try it on your own, but I'll try to do them for you real quick, okay? So I'm going to draw a circle, and then a small circle, and then a smaller circle yet, okay? Now, here's another way we can do it, okay? Like this, so it intersects once there. And then here, so that intersects once like this on the inside. That's one way that was not drawn down here, okay? And of course the big, well, there's one more circle, sorry, and then a little bigger circle. We'll make it about this size here, I guess. Would be on the inside also. Sorry about that, I missed that one. There we go, okay? Now, another way would be to have the 2 smaller ones on the inside with the bigger one here on the outside like this. That would be another way, okay? Now that I've shown you a couple of ways, maybe you're starting to think now and figure some of these out, okay? Another way would be to have the smaller one on the outside like this, and this one here on the inside right over here, okay? And then lastly, but not least obviously, we could have the medium-sized circle on the outside, and then this circle here would be tangent on the inside, okay? So there we go, just kind of a thinking problem, just to make you think outside the box a little bit, or think outside the circle, okay? Alright, let's continue on. Okay, students, let's go ahead and look at our last 4 problems here. And here we go. The directions for 37 through 40 say to complete the statement about circle P with either greater than, less than, or equal to, okay? So here we go. XP, right here. Now think about this, guys. The whole diameter is 10, so the radius from here to here is 5, right? So this length right here, XP, would that be greater than 5, less than 5, or equal to 5? Well, notice this point did not make it all the way out to the edge. If it did, this whole length would have been 5, but it did not. So this segment has to be less than 5. XP is less than 5, okay? Alright, number 38. XP is, well look, we have a radius here, it's 2, and we have XP is also a radius. So it also has a length of 2. So XP equals 2. XP equals 2. Number 39. We have an entire diameter of 14. Okay? And we know from here to here is 7. That's the radius. Now we're going to draw a line XP. Okay? Well, students, think about it. From here to here alone is 7, and the line goes much further than that, so XP has to be greater than 7. Greater than 7, okay? And then lastly, number 40, let's see, this radius right here is 1.5, okay? Well, XP is another radius, is it not? Sure it is. So how long is XP? 1.5. So if XP is 1.5, is 1.5 greater than 3, less than 3, or equal to 3? Well, XP, or 1.5, is less than 3. Less than 3. Okay? Alright, that's it, guys. I hope this homework video has been a help to you. If you have any questions, don't hesitate to call or email.